we are going to discuss about capacitors. And capacitance. అంటే కెపాసిటర్ అంటే ఏంటి, కెపాసిటెన్స్ అంటే ఏంటి? ఇది సింపుల్గా మనం ఎలా అర్థం చేసుకోవచ్చు అంటే, మన దగ్గర ఒక బకెట్ని మీరు కనుక ఉంది అనుకున్నట్లయితే, 2-3 రకాల బకెట్లు, 2-3 ఎక్కువ తక్కువ వాటర్ పట్టేటటువంటివి. అందులో ఏ విధంగా చెప్తాం మనం, ఒక బకెట్లో ఉండేటువంటి వాటర్ ఎక్కువ తక్కువ అనేది దాని యొక్క ఘనపరిమాణం. సార్ ఇందులో లోతు ఎక్కువ ఉంది, ఇది పొడుగు ఎక్కువ ఉంది, ఇది వెడల్పు ఎక్కువ ఉంది, ఈ విధంగా చెబుతాం. మరి కెపాసిటర్ అనేటటువంటిది దాంతో ఎలా కంపేర్ చేస్తున్నాం మనం అంటే, ఇందులో ఈ బకెట్స్ ఎవ్రీథింగ్ యు ఆర్ యూజింగ్ టు స్టోర్ వాటర్, రైట్? అంతేగా మనం నీటిని నిల్వ ఉంచుకోవడం కోసం బకెట్లు, గాబులు, ఇంకా వీలైతే ఓవర్ హెడ్ ట్యాంకులు, స్లంపులు ఇవన్నీ యూజ్ చేస్తూ ఉంటాం. ఒక్కదాన్ని బట్టి మనకి పట్టేటటువంటి వాటర్ క్వాంటిటీ అనేటటువంటిది చాలా ఎక్కువగా ఉంటుంది. సో ఇక్కడ ఈ కెపాసిటర్ అనేటటువంటిది కూడా ఒక డివైస్ యూజ్డ్ టు స్టోర్ చార్జెస్. కెపాసిటర్ ఈజ్ ఏ డివైస్ యూజ్డ్ టు స్టోర్ చార్జెస్. ఎప్పుడైతే ఛార్జెస్ని మీరు స్టోర్ చేస్తూ ఉంటారో ఆటోమేటిక్గా దాని యొక్క ఎలక్ట్రిక్ ఫీల్డ్ స్ట్రెంగ్త్ పెరుగుతుంది, పొటెన్షియల్ పెరుగుతుంది. ఓకే, అంటే ఇక్కడ ఏమైపోతుంది, మనకి ఈ ఎలక్ట్రిక్ ఛార్జ్ని మీరు స్టోర్ చేస్తున్న కొద్దీ, ఎందుకంటే క్యూ అనేటటువంటిది పెరుగుతున్న కొద్దీ ఈ పెరగాలి, వి పెరగాలి. కానీ ఇందులో ఒక చిన్న పాయింట్ని మనం జాగ్రత్తగా గమనించుకోవాలి. ఈ కెపాసిటర్ ఈజ్ ఏ డివైస్ యూజ్డ్ టు స్టోర్ చార్జెస్ and simply it is constructed with 2 conductors. Simply it is constructed with simply 2 conductors. Whenever you keep a conductor A and this is charged with the help of some battery, you may imagine, it is charged and the other side another another conductor I kept B near to it. What happens? After some time, due to induction, charge separation takes place. Charge separation takes place. Suppose this is a Q charge. If you imagine this is minus Q charge, equal and opposite. Why? Because in induction we will get equal charge, but opposite in sign you will get. And on this side automatically charge separation takes place, so this will become positive. This will become positive, simple. But the main point here it is, a capacitor is a device used to store charges. That is simply by showing you that 2 conductors A and B which are placed parallel to each other, so that conductor A is charged, B is a neutral conductor just kept near to it. After some time what happens, due to induction charge separation take place. Due to induction charge separation take place. So due to this charge separation, what happens to this? This negative charge always at low potential, and it would like to decrease the potential of A, and at B it is at a positive charge is always at high potential, so it will increase the potential of A. But how can we store charges? This is our main important contest. Actually, the main point you have to understand is this is a conductor, and in this conductor, as you keep charge, I told you the potential will rise and the electric field strength also rises. Here if you think about the potential Q proportional to V, and this Q is equal to some constant C into V, some constant C into V, లేదా C is equal to Q by V, C is equal to Q by V. So the capacitance of a capacitor is the ratio of charge on the conductor to its potential. Okay, this is defined as the ratio of charge on the conductor to its potential is known as its capacity or capacitance. You know, actually C is equal to Q by V, but generally C does not depend on Q and V. C depends on its geometrical things. C depends on geometry of the capacitor. That is shape, size, and distance, separation. And also dielectric medium also later we will discuss. But try to understand first about this. Whenever you keep charge on a conductor, the potential automatically rises. So the charge is directly proportional to potential. Charge is equal to some constant C into V. C is equal to Q by V. So the capacitance of a capacitor C is equal to the ratio of charge on the conductor to its potential. Then you may ask, sir, why are you keeping all this? Simply, we keep for storage purpose another neutral conductor near to a charged conductor, so that we can increase the capacitance of the capacitor. We can increase the capacitance of the capacitor. That's why generally you will take two conductors separated by some distance d simply. And a conductor A is charged. A is charged due to the phenomena of induction on this neutral conductor. Charge separation takes place. Later you have to keep this in ground so that the entire positive charge will be nullified, so that the capacity of A will increase. The capacity of A will increase. Why? Because there is only negative charge. Negative is always an acceptor charge. Okay, it always decreases the potential. It has always decreases the potential. So while you are constructing here, C proportional to 1 by V, if you observe, C proportional to 1 by V, if you think, is the potential decreases what happens to its capacitance? Will rise. That's why the working principle of this capacitor is nothing but keeping charges at low potentials. That means keeping charges, large amount of charges, keeping large amount of charges at low potentials is the working principle of capacitor. That's why we are taken two conductors. Okay, then what is the unit of this? See, the SI unit you can write here. SI unit of C, coulomb per volt, coulomb per volt, C per V, coulomb per volt, or farad, Michael Farad. So it's farad it is taken as. But farad is a very large unit. Farad is a very large unit. That's why in practice we use generally picofarad, microfarad. So micro means 10 power minus 6 in practice. Microfarad, picofarad, nanofarad, such type of things we will use. Generally we use more picofarad and picofarads, PF 10 power minus 12 farad. Why? Because 1 farad is very much large. Later we will discuss. In parallel plate capacitor we will discuss. This is also simply a parallel plate capacitor only. A simple idea about the charge when you keep, what happens to the potential. Now we are going to discuss about the parallel plate capacitor. Store in the capacitor is known as the capacity. Okay, generally you know that when you go for tanks, 200 liters tank, 100 liter tank, meaning that what you will understand, 100 liter of water it will fill. Like that the capacitor also we store charges, I told you before, and how much charge it is stored, that depends upon the capacity of the capacitor. That depends on the capacity of the capacitor. Now we are going to discuss about parallel plate capacitor. So in this parallel plate capacitor itself, it has meaning two parallel plates, conducting plates. You are going to take separated by some distance d. Separated by some distance d. And this plate A, plate B. A is charged to a positive potential, positive charge. Let the potential be, if you consider it as V1, and automatically it is separated by some distance. Obviously you will get here some equal negative charge. So equal negative charge you will observe here. And the surface charge density you may consider sigma. Surface charge density is sigma. And in parallel plate capacitor separated by some distance, meaning that the space between this is filled with air only. Air is a insulator. Air is a insulator. That means two plates separated by some distance. With respect between them, you have to keep a insulator. Here air itself acts as insulator only. Then what happens? Actually the field will from positive to negative. The field is acting like this. Whereas at edges, you will observe this bending of electric lines like this. Due to this bending of this is known as fringing effect. That means that the field is not uniform at the edges of these parallel plate. The field, electric field is not uniform. This bending is known as fringing effect. And the electric field, equation for the electric field E is equal to sigma by epsilon naught, where sigma is the charge density on these plates. And we know that sigma is equal to amount of charge on the plate to its surface area. Sigma is equal to amount of the charge on the plate to its surface area Q by A. If we substitute, what happens? E is equal to Q by epsilon naught A. E is equal to Q by epsilon naught A. Then from the relation between E and V, E is equal to V into V by D. Substitute here. If you substitute in the above equation, V by D is equal to Q by epsilon naught A. So Q by V is equal to epsilon naught A by D. But what do you know about Q by V? Capacity of the capacitor C is equal to epsilon naught A by D. C is equal to epsilon naught A by D. This is the equation for the capacitance of a parallel plate capacitor. Okay. Whenever if you go here, capacitance is equal to permittivity of the free space multiplied by the area of the plates to the separation distance between the plates. So C is equal to epsilon naught A by D. C is equal to epsilon naught A by D. And I told you Farad is a very big unit. That means you may consider how. Means I am taking epsilon naught value 8.85 into 10 power minus 12 Coulomb square by Newton meter square. Okay, it is a epsilon value, and I take 1 meter square area of the plate separated by a distance of 1 millimeter. That means very less. That is, if epsilon naught is equal to 8.85 into 10 power minus 12 Coulomb square Newton inverse meter power minus 2, and the area of the plate A is equal to 1 meter square, and the separation distance D is equal to 1 millimeter. So milli means how much? 10 power minus 3 meter. If we substitute in this, what happens? C is equal to 8.85 into 10 power minus 12 into 1 by 10 power minus 3. When it 10 power minus 3 moves up, 10 power plus 3 minus 12 plus 3 minus 9. So C is equal to 8.85 into 10 power minus 9 farad. Okay, from this we have to check about how much area of the plate we need to understand about a farad. So how to understand the 1 farad is a very big unit. So in typical values, it depends on the geometry. Here A area of the plate, so D separation between the plates, so epsilon. I told you air medium will be taken in between the separation of the plates, permittivity of the free space or vacuum we can consider. Then now we are going to understand about how much big C is 1 farad is equal to. For that, if 1 coulomb of charge is utilized to raise the potential through 1 volt between the plates, then C is equal to, according to the formula, Q by V, and Q is equal to 1 coulomb, V is equal to 1 volt, then C is equal to 1 farad. Coulomb per volt accounted as farad. Then to get 1 farad charge on a capacitor, we will understand now how much area of the plate you needed, how much area of the plate you may needed. So in the formula, C is equal to epsilon naught A by D. A is equal to CD by epsilon naught, and if you take in typical values, C is equal to 1 farad, D is equal to 1 millimeter, separation distance 1 into 10 power minus 3 meter, and epsilon value 8.85 into 10 power minus 12 Coulomb square Newton inverse meter power minus 2. Then A is equal to 1 into 10 power minus 3 by 8.85 into 10 power minus 12. Okay, don't bother about 1 by 8.85. First of all, think about this. 10 power minus 3 into denominator 10 power minus 12 మూవింగ్ అప్ సైడ్. ఇది కనుక పైకి వచ్చేసినట్లయితే మనకి 10 పవర్ మైనస్ 12 అవుతుంది. ఇది 10 పవర్ ప్లస్ 12 అవుతుంది, మైనస్ 12 పైకి వస్తే. సో ఇక్కడ మీకు అప్రాక్సిమేట్లీ యూ మే అకౌంట్ ఇట్ యాజ్ 1 by 8.85 into 10 power 9 మీటర్ స్క్వేర్. అంటే అర్థం చేసుకోండి జాగ్రత్తగా, 10 పవర్ 9 మీటర్ స్క్వేర్ ఉండేటటువంటి ఏరియా ఆఫ్ ప్లేట్ కావాలి మనకి. 1 ఫారడ్ ఛార్జ్ అనేటటువంటిది మనం కెపాసిటర్ మీద స్టోర్ చేయడానికి. అప్రాక్సిమేట్లీ ఇది ఎంత అవుతుంది అంటే దగ్గరగా ఒక 30 కిలోమీటర్స్ దాకా వస్తుంది ఏరియా ఆఫ్ ది ప్లేట్. కాబట్టి 1 ఫారడ్ అనేటటువంటిది వెరీ వెరీ లార్జ్ యూనిట్ ఆఫ్ కెపాసిటెన్స్. కాబట్టే మనము మైక్రోఫారడ్ని లేదా పీకోఫారడ్స్ని యూస్ చేస్తూ ఉంటాం. మైక్రోఫారడ్స్ని పీకోఫారడ్స్ని అందుకని యూస్ చేస్తూ ఉంటాం మనం. అట్లాగే C is equal to capacitance of a capacitor. C is equal to epsilon naught A by D. ఇది ఫార్ములా. ఎయిర్లో ఉన్నప్పుడు దీన్ని C0 అనుకున్నా అనుకోండి నేను. ఓకే, ఇందులో మనం ఎటువంటి డైఎలక్ట్రిక్ అయినా మనం తీసుకున్నా దాని డైఎలక్ట్రిక్ కాన్స్టెంట్ అనేటువంటిది K అనుకున్నట్లయితే డైఎలక్ట్రిక్ కాన్స్టెంట్ K అనుకున్నట్లయితే ఎప్పుడైతే ఛార్జ్డ్ కెపాసిటర్లో ఆ డైఎలక్ట్రిక్ని పెడతామో కెపాసిటీ అనేటువంటిది ఏ విధంగా ఇన్ఫ్లుయెన్స్ అవుతుంది. చాలా సింపుల్గా అర్థం చేసుకోవడానికి ప్రయత్నం చేద్దాం దీన్ని. ఇందులో సర్ఫేస్ ఛార్జ్ డెన్సిటీ మూలకంగా ఇది పోలరైజ్ అవుతుంది. అప్పుడు దీని వచ్చేటప్పటికేమో సిగ్మా ఛార్జ్ డెన్సిటీ, దీని వచ్చేటప్పుడు సిగ్మా పి ఛార్జ్ డెన్సిటీ. దీని నుంచి చెప్పుకోవడం ఒక పద్ధతి మనకి. లేదు, ఎయిర్లో ఉన్నప్పుడు C0 ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ నాట్ A by D. ఇది ఫార్ములా. ఎప్పుడైతే దీస్ ఫిల్డ్ విత్ సమ్ డైఎలక్ట్రిక్, వెన్ ఇట్ ఈజ్ ఫిల్డ్ విత్ సమ్ డైఎలక్ట్రిక్, ఇఫ్ ఐ ఇమాజిన్, ఓకే, ఒక డైఎలక్ట్రిక్తో ఉన్నది అని చెప్పి మనం ఎప్పుడైతే ఇమాజిన్ చేసుకుంటున్నామో ఆఫ్ కాన్స్టెంట్ K, దాని కెపాసిటెన్స్ C ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ A by D, వేర్ ఎప్సిలాన్ ఈజ్ ద పర్మిటివిటీ ఆఫ్ ది మీడియం. So epsilon is the permittivity of the medium placed between the dielectric, between the plates of the capacitor. Then we have epsilon is equal to K epsilon naught. Epsilon is equal to K epsilon naught. If you substitute in this C dielectric, if you keep dielectric DIE, that is considered as C only. C is equal to K epsilon naught A by D, that is equal to K into epsilon naught A by D from equation 1, C only, C naught. So C is equal to K epsilon naught. That means when you keep a dielectric between the space, when you keep a dielectric between the space of this parallel plate capacitor, the capacitance of the capacitor increases by K times. The capacitance of the capacitor increases by K times, where K is dielectric constant. Where K is dielectric constant. This can be understood in a different way also. But what happens due to this dielectric thing? Okay, here due to this dielectric, polarization take place, so that inside a field is developed in it. Inside a field is developed in it. And in terms of this dielectric and dielectric properties, we will discuss further. Okay.